In this video, we're going to talk about section 1.4. In particular, we're going to focus on predicates and get to quantifiers in the next video. So let's just talk about what a predicate logic is. So let's look at an example. Suppose we have this statement, all men are mortal, and then we're told Socrates is a man. Does it follow then that Socrates is mortal? Well, I mean, we obviously have reasoning skills that say yes, but what we can't do is look at an argument and use the propositional logic we've talked about before, where we've labeled things P and Q. Okay, that's not enough to be able to describe what's going on in these kind of arguments. So we're going to introduce a new way of writing the arguments, and that's using predicates. So predicate logic uses the following new features. So we will have variables and, we'll traditional X, Y, Z. The predicates themselves are going to take on like function notation. P of X or M of X are common for this textbook. And then quantifiers, to be covered in a few slides. Sorry, this was taken from a PowerPoint. We'll talk about in the next video. Okay, so let's start with how propositional functions kind of work. They contain a variable and a predicate, and the variables can be replaced by elements in their domain. So let's kind of look at some examples. Before we do that, they can have truth values. They can be true or false. Okay, so let's look at an example. I think that'll make it a little bit easier. So let P of X denote X is bigger than 0. And the domain is integers. So P of -3. Okay, so P of -3 is kind of problematic, right? Because if the P of X is supposed to be X is bigger than 0, then this is false because -3 isn't bigger than 0. So is part B, because 0 doesn't work. It has to be bigger than 0. So this is the only one that actually comes out true. It actually has a truth value, okay? In this case, the domain being the integers, they often use U to represent domain in this book. Okay, so here, let's look at another example. Let's say this time we are looking at X plus Y equals Z, all right? And let's denote that with the function notation R of X, Y, Z, okay? And U are integers, okay? So all of these are integers. So let's look at these truth values. Okay, so X plus Y equals Z. So the question is, does 2 plus -1 equal 5? It does not. 2 plus -1 does not equal 5. Therefore, this is false. All right. 3 plus 4 does equal 7. So this one works. That one's true. Okay, now this is not true or false because we didn't actually plug values in for the numbers. So this is not a proposition. So it needs to have true or false values in order to actually count as a proposition. Okay. So let's look at another one. Let's say it's going to be X minus Y equals Z. Okay. This time using Q instead of R. So in this case, the first one actually works. The second one does not. And again, the last one is not a proposition. So you can assign neither true nor false value to it. All right. Okay, so connectives carry over. And what I'm talking about with connectives are the and, or, the implies, all of those. So the and, the or, the implications, the not, when you say not, okay? All of those that we talked about previously can actually carry over into this, okay? So if we use P of X being X is bigger than 0, okay? We can assign truth values to these solutions, all right? So in this case, we have the case of, okay, the first one, P of 3 is true, but P of -1 is false. However, since this is or, the whole thing would become out true, because with or, true is what we assign when we can. Okay. However, if it's and, that becomes false because and will always take false if false is available. All right. Oh, for implication, so true giving us false, that's a problem. Can't have it. However, if we put the negation symbol in front, right, that negation symbol right there, that's what that is. That means that we actually end up get with true implies not false, or true implies true. So this is true. Oops, sorry, moved a little too fast. Okay, and then expressions with variables are not propositions and therefore do not have truth values. So with x's and y's being thrown in there, they do not actually contain truth values, which we already talked about, but stated it in an actual note. Okay, we'll save quantifiers for the next video.